Dear students, in this video you will learn about electrolysis and electrolytic cell, Faraday's laws, process of electrolysis in certain ionic compounds. Let's get started with electrolysis. It is defined as the process of decomposition of an electrolyte by the passage of electricity through its aqueous solution or molten state. To understand this, let us take a voltmeter. In this voltmeter, we have taken copper sulfate as electrolyte and copper as electrodes. So these electrodes are made of copper. One of these electrodes is connected to negative terminal of battery and another is connected to positive terminal of battery. The electrode which is connected to negative terminal of battery is called cathode, whereas the electrode which is connected to positive terminal of battery is called anode. Remember, reduction takes place at cathode and oxidation takes place at anode. Now let's try to find out how current or electricity passes through this electrolyte. At cathode, reduction takes place. How does it happen? Negative terminal of battery gives electrons. These electrons are accepted by copper 2 positive ions at cathode. As a result, copper 2 positive ions get reduced. At anode, copper atoms of this electrode lose electron to become copper 2 positive and they go into the solution. The electrons lost by copper atoms move towards positive terminal of the battery. So in this way, there is flow of charge in the circuit. In the outer circuit, electrons are there which carry charge. In the inner circuit, ions are there which move and lead to flow of electricity. So this is how electricity is flowing through the electrolyte. Now this flow of electricity is possible because of the oxidation reduction reaction that are happening at these two electrodes. So here decomposition has taken place. Copper 2 positive, they've got reduced. No doubt here copper 2 positive ions from somewhere outside, they are coming into the solution. They are coming from electrode. So you think that there is no change happening. But then if you take another electrode, some other reaction will happen. But on the whole, ions from electrolyte, they've got reduced. They've got reduced. You can see. So it means some chemical change is happening inside, and because of that only this conduction of electricity in the electrolyte is possible. So this passage of electricity is leading to chemical reactions in the electrolyte. This is called electrolysis. Similarly, we can take another example. Let us take example of sodium chloride, molten sodium chloride. So if you electrolyze molten sodium chloride, what happens? Na positive ion will move towards cathode. They will get reduced and Na positive will change to sodium atom. Cl negative ion from molten NaCl will go to anode. They will get oxidized and Cl negative ions will change to Cl2 gas. So here you can quite easily understand and clearly understand how decomposition is happening. Due to passage of electric current, sodium positive ions have changed to sodium atoms and chloride ions have changed to chlorine gas. So this is decomposition of the electrolyte. NaCl has changed to Na and Cl2. This is called electrolysis. Decomposition of electrolyte by the passage of electric current through it. Faraday's laws of electrolysis. Michael Faraday was an English scientist. He is known for his research work in the field of electromagnetic induction and electrochemistry. These two laws are simply relationships published in his research of electrochemical processes. Let us study what is first law of electrolysis. The amount of any substance deposited or liberated at any electrode during electrolysis is directly proportional to the quantity of electricity passed through the electrolyte. Okay, take a look at this diagram again. Here copper was getting deposited because of reduction of copper to positive ions. Now the amount of this copper deposited, say it is W, depends on the amount of charge or electricity which you pass into the solution. Right? This is first law of Faraday. The more the electricity you pass into the solution, the more will be the amount of substance deposited or liberated. Right? So W is proportional to Q. We can write it in a different mathematical representation like this. W is equal to ZQ. What is Z here? That is called electrochemical equivalent. Now Q can be written as I into T. So this mathematical representation can further be written as W is equal to ZIT. Now what is Z here? How can we define it? Okay, take I as 1 ampere, T as 1 second. So Z can very easily define. Z now becomes equal to W. So Z can be defined as the mass of substance deposited or liberated when 1 ampere of current is passed through its electrolytic solution for 1 second, or it is the amount of substance liberated or deposited when 1 coulomb of charge is passed through its electrolytic solution. So this is first law of electrolysis. Second law of electrolysis. This law states that when same quantity of electricity is passed through different electrolytic solutions connected in series, the weights of the substances produced at electrodes are directly proportional to their chemical equivalent masses. Okay, so let us try to understand this law with the help of these three electrolytes. So we have three voltammeters here. This voltmeter contains silver nitrate solution with silver electrodes dipped in it. This contains copper sulfate solution with copper electrodes dipped in it. And this voltmeter contains gold chloride solution with gold electrodes dipped in it. These three voltmeters are connected in series. So here we have three electrolytes connected in series. Right? So when you pass electric current through them, same amount of current will flow, or same amount of charge or electricity will flow through these. Let us suppose that we make 2 farad electricity pass through these three. 2 farad. Okay? 2 farad. Now, silver positive needs 1 electron to become silver. It means 1 farad electricity will produce 1 mole of silver, that is 107.87 gram. 2 farad will produce 107.87 into 2, that is 215.74 gram. Copper 2 positive needs 2 electron to become copper. It means for reduction of copper 2 positive we need 2 electron. So 2 farad in terms of mole, 2 farad electricity will produce 63.5 gram, that is 1 mole of copper. Now Au3 positive needs 3 electron to become Au. It means 3 farad in terms of number of moles. 3 farad charge is required to produce 1 mole of gold, that is 197 gram. So 2 farad of electricity or charge will produce 197 into 2 upon 3, that is 131.3 gram gold. With 2 farad we can produce 215.74 gram silver, 63.5 gram copper and 131.3 gram gold. Now let us see the equivalent masses of silver, copper and gold. Silver 107.87, copper 31.77, gold 65.66. So these are in this decreasing order: silver highest, followed by gold, and last is copper. Now if you compare these masses, you can get this order. Now we can see that both the orders are same, and hence the law which we are discussing is verified. It means that masses of substances deposited, right? Masses of substances deposited are proportional to their equivalent masses. Higher the equivalent mass, more will be the mass of a substance produced. Clear? So let us discuss this again. Same quantity of electricity is passed through different electrolytic solutions connected in series. The weights of the substances produced at electrodes are directly proportional to their equivalent masses. That's what we have seen, right? Silver has highest equivalent mass. So the mass of the substance produced here when we pass 2 farad electricity through all is highest. It is followed by gold, because gold has next highest equivalent mass. Copper has least equivalent mass, so the amount of copper deposited here is the least, that you can see here, right? 63.5 gram. For gold it is 131.3. For silver it is 215.74. So this, for silver it is highest, for gold second highest, for copper it is least, and it is exactly as per the order of their equivalent masses. Okay, next let us now discuss electrolysis of different substances. Electrolysis of water. So for electrolysis of water, we make this kind of an arrangement. This is H-shaped tube, Helmholtz tube. This electrode is cathode and this one is anode, negative terminal connected to positive terminal. These electrodes are made of graphite. So when you pass electricity through water which is slightly acidified or which is made alkaline, you know why? Because pure water doesn't conduct electricity. So we have to make it little alkaline or acidic so that its ionic product increases and it starts conducting electricity. Now, at cathode, what will happen? H positive ions, right, from water will receive electrons, will gain electron, and they will change to H2 gas. So it will bubble up and get connected here. Similarly, at anode, what will happen? Oxidation. OH negative ions from water will lose electron to become water and oxygen. So this oxygen will move up and get connected at the top there. If you compare the volume of oxygen and hydrogen produced, you will get this ratio 2:1, H2 and O2, right? So the volume of H2 and O2 produced are in the ratio 2:1. So this is how electrolysis of water take place. Electrolysis of sodium chloride. These are the ions which are present in aqueous sodium chloride solution. At cathode, these two reduction reactions are possible, but the reduction potential of hydrogen is more than reduction potential of sodium. So that's why the reaction which is highlighted here will happen. H positive will gain electron and hydrogen gas will be produced. However, at anode, there is something which is little difficult to understand, but then I hope I'll be able to make you understand with a nice reasoning. Look here, chloride ions can lose electron to become chlorine gas. Reduction potential is 1.36 volt. Water can oxidize to become oxygen and H positive. Here reduction potential is 1.23. So you will straightway, after seeing the reduction potential, think that water will get oxidized. There will be production of oxygen, but it doesn't happen like that. In case of water, what happens? This oxidation reaction happens in two steps. First, water changes to hydrogen peroxide, and then that hydrogen peroxide changes to oxygen and H positive. This first step has higher reduction potential, that is minus 1 that is 1.78, okay, plus 1.78, whereas this second one has minus 0.6. Now look at the first step, 1.78 plus 1.7, which is higher than the reduction potential of this first step. So as a result, what happens, this first step is more feasible, and that's why, I mean, this is not first step actually, this reaction which I have written here above, the oxidation of water, this is more feasible, and that's why this happens. As a result, at anode there is production of chlorine, not oxygen. So I'll again make you understand why it happens like that. Seeing the reduction potential, oxidation of water should take place, but in reality, oxidation of chloride ion takes place. There is production of chlorine, and it happens because of over voltage. Because in the oxidation of water, right, there are two steps. The first step has higher reduction potential, that is 1.78, okay, and that is quite higher as compared to reduction potential of this reaction, okay, this oxidation reaction, and that's why this is more feasible, and this only happens, right? So there is production of chlorine. Electrolysis of copper sulfate, this we have already discussed. Now let us discuss this using platinum electrodes. Let's go back. Okay, so now the electrodes are different, they are not copper electrodes. This reaction will be same, because copper 2 positive ion from solution will gain electrons at cathode and will get reduced, so copper will get deposited at cathode. However, here electrode is platinum, so copper 2 positive ions can't be produced, right? So at anode reaction will be different. Now here water will get oxidized. So now let's go back and see what happens at anode. At anode, water gets oxidized, it changes to 4H positive oxygen, right? So oxygen is produced at anode. Here copper 2 positive ions were being produced because of oxidation of copper electrode at anode. Here oxygen is produced, so there is difference between these two, and this difference is because of difference in the material of electrode. Now let us discuss electrolysis of sulfuric acid. So whether you take dilute sulfuric acid or concentrated sulfuric acid, at cathode reaction will be same, because these are the ions which are there in dilute or concentrated sulfuric acids. Now problem is the reaction which takes place at anode. When we take dilute sulfuric acid, we have more of OH negative as compared to SO42 negative. So as a result, OH negative gets oxidized to produce oxygen. Whereas when we take concentrated sulfuric acid, SO42 negative ions are more as compared to OH negative. So they get oxidized to produce H2O8, peroxo disulfate, right? So in fact, the product of electrolysis of concentrated sulfuric acid is peroxo disulfuric acid, right? Okay. In the end, we have a numerical. In this numerical, look, we have an electrolytic solution. In that electrolytic solution, 1.5 ampere current is passed for 10 minutes. You have to calculate the mass of copper deposited. Current is given, time is given, change time into seconds. Find the amount of charge passed into the electrolyte. That can be calculated as 1.5 into 600 using the formula I into T. So charge is 900 coulomb. For getting 63.56 gram, that is 1 mole of copper, we need 2 farad electricity. That is 2 into 96500 coulomb will produce 63.56. So 900 coulomb will produce 63.56 divided by 2 into 96500 into 900. So answer is 0.296 gram. Right? So I hope you have understood the topics taught in this video. Thank you.